So let's finish off chapter 5 of this lecture series on CCNA cyber operations with me, Joachim Kävrestad, at the University of Skövde. I realize now that I usually say cybersecurity or cyber operations or cybersecurity, but it's actually called cybersecurity operations. Okay, who cares? Let's finish this off with taking a few words on network representations. What we're going to talk about is topologies and architectures, and essentially those are things you use, or topologies at least, are used to keep track of devices, services, and media in a network. So topology maps are used to document the network layout, and I say this so many times to the students, but documentation is key to having a proper work with network as well as security, because it allows you to know what's going on and understand the network quickly. Consider having a network consisting of, let's say, 50 servers and 500 clients, and one cable breaks down, rendering some users lose connectivity. How are you going to find that without having a topology that shows the network layout? How should you know where that cable is? And there are stories of people, myself included, having to go on a treasure hunt for a server that just worked for a couple of years, then decided to stop working, and then people go like, where the hell is it? And it's not fun, and it's not good. So you should ensure that you keep track of your devices with proper documentation, and topology maps is one key part of proper documentation. We actually have two kinds of topology maps, where the first are the physical topologies that we use to document the physical network layout, which is essentially where network devices are placed and how they are physically connected to one another. Then we have the logical topologies that are used to document how they are logically arranged and usually contain what services a device hold, their IP addressing, and stuff like that. So moving on from the topology maps to talk about some different topologies. I want to tell you now that this material separates topologies into wide area network and local area network topologies. I'm not really sure if I see that distinction, but let's teach it like that. Any topology can, in theory, be used, or more topologies can be used as wide area network topologies than those three, and those three could be used as local area network topologies. I don't understand why not. Okay, anyhow, wide area network topologies. First, we have the point-to-point topology, which is just one site that is directly connected to another using a single link. Very simple. We have hub and spoke, which is a topology where we have several sites connected to one central site. So we have one master site, if you will, and we have all the different other sites connected to the master site, and all traffic goes through there. And then we have a mesh topology where all sites are connected to each other, which is best for performance because we have the most routes and we have no single point of failures and stuff like that, which is very good. And we can also have partial mesh where some sites are connected to some other sites, reaching full connectivity. Moving on to the local area network topology, we can begin with the star topology, which is very similar to hub and spoke, because all devices are connected to a central intermediary device, such as a switch. So this is perhaps the most common local area network topology. We also have the extended star, which is essentially several star topologies that are connected to each other. So you have stars where you have a number of devices connected to a switch, and then you connect the switches to each other, and you have an extended star topology. Then we have the bus, which is an older topology where all devices are chained to each other and terminated in both ends. So you can see it as a string that you connect all devices to. And then we have the ring topology, where each end system is connected to both of its neighbors, so that the topology in itself forms a ring. Those are the local area network topologies. So let's move on to just briefly introduce the Cisco three-tier design model, or three-level design model, or hierarchical design model, or whatever it's called in this specific course. It's a 3-level network design model that provides or that includes 3 different layers in which you design a network. So first we have the access network that is there to provide endpoints with access to the network. We have the distribution layer that aggregates access layers and provides connectivity to services. And then we have the core layer that provides high-speed connection for distribution layers. And smaller networks usually combine the core and distribution layer, and then it's called a collapsed core network design. And if we want to look at this a little bit more graphically, you can see that we have the access layer down here with some tablets, IP phones, and the clients that connect to access layer switchers. And then we have the distribution layer that in this case is made up from layer 3 switches and aggregates the different or connects the different access layer switches. You could have a server park here as well connected to the distribution layer to provide some services. And then we have a high-speed core that that provides internet access and combines the distribution layer switches. So that's the normal 3-tiered network design model. There are also some security architectures, and implementing firewalls is essentially about deciding the level of trust in different parts of the network and deciding how different parts of the network can communicate with each other and the outside world. The simplest way of doing this is simply to consider the inside network trusted and the public outside network untrusted. And if you have such an architecture, you would basically allow the inside network to initiate communication with anyone and communicate inside itself in whatever way it wants to, but block all connections originating from the outside. However, that's not always feasible because you may have servers that actually provide services to the outside world. Your company may have a mail server, or DNS server, or web server that you actually want to have accessible. One way you can implement this is by the use of a demilitarized zone, or DMZ. So with this layout, you would have the firewall in the middle, or firewall like so, and you will have a private inside network. The private inside network, and then you have the internet, of course, and you have a demilitarized zone. All services that should be accessible to the outside world, you place in the demilitarized zone. And then you allow your inside network to communicate with the demilitarized zone and with the internet. But you don't allow the demilitarized zone to communicate with your inside network, and you do not allow the internet to communicate with your inside network. And then, of course, you let the demilitarized zone communicate with the internet and the other way around. And the idea here is that the devices that you placed in the DMZ are, of course, more easy to attack for an attacker because they're accessible. But if those are taken over, or if these devices are compromised, this should not be a possible attack vector into your inside network, where you store data, where you store services that only have to be available for the internal network and sensitive information and such. You can also do zone-based firewalling, which is essentially the same as having a DMZ, but you can have several different private networks, and you can either let them be member of the same zone, or you can have different zones with different security layers, and this basically allows you to group machines together and have different security policies for different zones. So that's it for the last part of chapter 5 in this course. We almost reached half stage, and we will talk about fundamental network security in the next chapter. And from here on in, things are going to get more structured. So if you made it through this, you should have a smooth ride to the end of the course. It's sort of like reading The Lord of the Rings, the Lord of the Rings book, where book number 3 is a very, very, very good book, one of the best books I've ever read. And a lot of the second book is also very, very good, but you have to sort of make it through the first 500 pages to get to the good stuff. It's the same thing with this course, with the downside of instead of reading it in a warm seat at a beach with a nice drink, you're on YouTube listening to me. But whatever. So I'm ending this here. Feel free to leave any comments in the comment field, and see you next time where we'll actually start to discuss security.